Hello my dear friends, welcome to another very interesting video lecture. Self-reciprocal function. As we know already, it's a Fourier transform. The input is f of x, outcome is f of s. But this time see that whatever we have small f means here also small f. So what's the meaning that? That means that the Fourier transform of f of x is equal to f of s. Simply in the place of x replaced by s, because as we know that the input variable is x, the outcome is s. So here whatever we applied into the term, the output is the same function in the place of x by s. In example, suppose the input is e to the power minus a squared x squared. The Fourier transform of e to the power minus a squared x is nothing but e to the power minus a squared s squared. Yeah. That means that just replacing x by s and the Fourier transform, then we say that such functions are called self-reciprocal. This function itself becomes here just like a mirror reflection. The output is s. So this concept. Now here I want to find out the Fourier sine and cosine transform of. I want to find out the Fourier sine and cosine transform of x power n minus 1, where the limit, the range of n is 0 and 1, and hence prove that 1 by root x is self-reciprocal, and hence prove that the function 1 by root x is self-reciprocal under both the transform, both the sine and cosine transform. So that is a concept, correct? So I want to prove that x power n minus 1 is the Fourier sine transform and the cosine transform. First find out those values and then prove that this function is self-reciprocal. If I take x equal to, that is n equal to 1 by 2, I think n equal to 1 by 2, we get x to the power 1 by 2 minus 1 equal to x power minus 1 by 2, otherwise it is 1 by root x. So I may get this function, but I want to first get what is the Fourier sine and cosine transform of f of x. What's the Fourier sine and cosine transform of x power n minus 1? Okay. Then after that 1 by root x is self-reciprocal. So 1 by root x is self-reciprocal means what's the mean that Fourier sine transform of 1 by root x is equal to 1 by root s. Similarly, to prove that the Fourier cosine transform of 1 by root x is equal to 1 by root s, because as I told you that just replace x by s is called self-reciprocal function under the both the transforms, sine and cosine transform. So what I am going to do that? Yeah. So my aim is to get x power n minus 1 for a sine and cosine transform. This time I am going to use the gamma function. I made a separate video for gamma function, isn't it? Please go and watch it. So what's the gamma of n? Yeah, gamma of n is equal to integral 0 to infinity. It is for minus x power n minus 1 into dx. So you may know why I am using the gamma function, because of x power n minus 1. So that is my required function, x power n minus 1. So that's why I use the gamma function. Now can I take x is equal to some at, some proper substitution at. So what about dx by dt is equal to a, otherwise dx is equal to a into dt. So now this gamma of n becomes 0 to infinity. Yeah, when x equal to 0, t equal to 0. When x equal to infinity, t equal to infinity. E to the power minus x, what's the x here? At. What about x? X is equal to at, yes, at whole power n minus 1. What about dx? Dx equal to a into dt. The left hand side is gamma of n. Yeah. So I think a power n minus 1 to a power 1 is a power n. So a power n is outside, integral 0 to infinity, e to the power minus at into t power n minus 1 dt. The left hand side is gamma of n. So first I can rewrite this by gamma of n equal to this model. Now here what about the a? A is the constant. A is the constant. So can I rewrite the a by is? Yeah. Now I can do once again one more substitution here. Take a equal to the complex constant is. As I told you that this comes into the Fourier transform. So complex Fourier transforms already you know. I can make it into the complex Fourier transform first, then I can equating the real and imaginary parts, which will give the required Fourier sine the cosine transform of x power n minus 1. So I need to replace t by x. I need to replace t by x. So what happens on the left hand side? Gamma of n is equal to a power n into a power n is a power n integral 0 to infinity e to the power minus a into, what about t now? Sorry, a is is. So a is is into t equal to x. Now t equal to x n minus 1 dx. T equal to x. Is right? Now this is looks like somewhat the required function x power n minus 1. Is right? Now can I rewrite this 0 to infinity? X power n minus 1 e to the power minus isx into dx is equal to gamma of n by a power n. Right? A power n, gamma of n, everything is correct. Very good. Here e power minus isx. Can I rewrite this e to the power minus isx by, because I want to prove that this for Fourier sine and cosine transform. So I want to rewrite the exponential term by the Fourier sine and cosine transforms. And even though I am not able to rewrite the a equal to is here, so when I substitute a equal to is, what happened? So is whole power n, right? So this also becomes is whole power n. So this is equal to gamma of n by s power n into I power n, otherwise gamma of n by s power n into I power minus n, I power minus n, I to the power minus n. So this can be written as gamma of n by s to the power n into I can be written as 0 plus 1 into I power n minus n. Right, sir? 0 plus, what is 0? So this is the equivalent complex form of the given value I can be written as real part is 0, imaginary part is 1 time I, minus n is there. I want to rewrite the left hand side in terms of trigonometry function as well as the right hand side in terms of trigonometry function. So first I can go for the left hand side. What's the e power minus isx? This thing but cos sx minus I sin sx into dx. At the same time, the right hand side, I am going to rewrite this 0. When we get 0 under the trigonometry function, cos pi by 2. So cos pi by 2 is 0. When we get 1 under the pi by 2, sin pi by 2. So sin pi by 2 is 1 into I. So I into sin pi by 2 minus 1. Alright, sir? Once I repeat this, I can rewrite the exponential term as well as the complex numbers into the trigonometric terms cos and sin. Because of, I need to find out for a sine the cosine transform of x power n minus 1. So that is the concept. Right? Right? Now, can we equating the real imaginary parts both these sides? What we'll get? Can we equate the real imaginary parts on both these sides? What we'll get? Let us see that. Before going to that, this minus n by using the De Moivre's theorem, this gamma of n by s to the power n cos of n pi by 2 minus I into sin of n pi by 2. By using the De Moivre's theorem, the power gets down into the multiples of x, that is angles. Now if I compare the real and imaginary parts, we compare the real and imaginary parts on both the sides. So equating the real and imaginary parts, what will get? Equating the real and imaginary parts. Equating the real and imaginary parts on both the sides. What will get? Left hand side 0 to infinity x power n minus 1 cos sx into dx minus is equal to, this is the real part, right? This is the real part. What is the real part here? Gamma of n by s power n into cos n by d. So gamma of n by s power n into cos n pi by d. Is it? What about the imaginary part? What about the imaginary part? The imaginary part is nothing but integral 0 to infinity x to the power n minus 1. I think minus is there, here also minus is there, so we can cancel the minus minus. And x power n minus 1 into sin sx into dx is equal to gamma of n by s to the power n sin n pi by 2. Right? Because minus minus to cancel, I is the imaginary part. But my question is ultimately to get the Fourier sine the cosine transform. Yeah, almost we reach the answer, but root 2 by pi is missing here, right? So when I multiply root 2 by pi on both these sides, what we'll get? This side becomes the Fourier cosine transform of x power n minus 1. At the same time, this side we multiply root 2 by pi. So we multiply root 2 by pi, root 2 by pi. The left hand side becomes Fourier cosine transform of the x power n minus 1 into gamma of n by s power n into cos n pi by 2. Similarly, when I multiply root 2 by pi both these sides, the left hand side becomes Fourier sine transform of x power n minus 1 is equal to square root of 2 by pi gamma of n by s to the power n sine n pi by 2. So this is the first part of the given question. Find the Fourier sine and cosine transform of x power n minus 1. What is the range of n? The range of n is 0, strictly less than n, strictly less than 1. But after getting this, so this is the first result, this is second result. After getting that, I want to prove that 1 by root x is self-reciprocal under sine transform and cosine transform. So what's the meaning of self-reciprocal? The f of x means f of x. So 1 by root x means the output is 1 by root x. 1 by root x means 1 by root x. Under the sine and cosine transform. And can I take the n value? What is the n value here? 1 by 2, because as I given the range here 0 and 1. So I pick n equal to 1 by 2 because root x, what's x? Root x means x power 1 by 2. So how to get the root x? Taking the n equal to 1 by 2, substitute n equal to 1 by 2 in the first equation. I am getting that for the cosine transform of x power 1 by 2 minus 1 is equal to, what's x power minus 1 by 2 minus 1 minus 1 by 2, otherwise for the cosine transform of 1 by root x is equal to root 2 by root pi root gamma of 1 by 2 by s power 1 by 2 into cos n is equal to 1 by 2 now. 1 by 2 into pi by 2 is pi by 4. So cos pi by 4. Right? So this is equal to root 2 by root pi. What is the gamma of 1 by 2 value? Gamma of 1 by 2 value is root pi. I made separate video. Please go and watch it. Root yes. What's the cos pi by 4? Pi by 4. Cos 45 degree. 1 by root 2. Right? So 1 by root 2 will cancel. Root pi will cancel. Doubt is 1 by root yes. So for a cosine transform of 1 by root x is equal to 1 by root s. That means that it is self-reciprocal under the cosine transform. It is self-reciprocal under the cosine transform. Under the cosine. What about the sine transform? The same way, substitute n equal to 1 by 2 here. We get for a sine transform of x power minus 1 by 2 is equal to root 2 by root pi gamma of 1 by 2 by s power 1 by 2 sine of n equal to 1 by 2 now. 1 by 2 to pi by 2 is pi by 4. So again we get root 2 by root pi gamma of 1 by 2 value is root pi and this is root s. Sine 45 degree is 1 by root 2. Root 2 will cancel. Root pi will cancel. So this is 1 by root s. So for a sine transform of 1 by root x is equal to 1 by root s. So this is also self-reciprocal function under the sine transform. So this is the concept behind the self-reciprocal function with the help of gamma function. Why I use gamma function? Because of x power n minus 1. So I use the gamma function concept. Okay, thank you. Thank you so much for watching our YouTube channel. Please kindly subscribe, share, and also recommend to your friends so that they also got benefited. Okay, thank you. Please kindly follow our YouTube channel ADC Max. Thank you so much. Bye.